All right, let's get into it. Today, we're going to talk about one of the internet's unsung heroes, a piece of tech that makes so much of what we love online even possible. We're going to look at this fundamental trade-off that's right at the heart of how the internet works, this constant tug of war between getting things absolutely perfect and getting them there incredibly fast.
You know that feeling, right? You're on a super important video call, and all of a sudden the audio goes all robotic, or the video just freezes for a second. Well, that's not just some random internet hiccup. It's actually the result of a very deliberate choice. A choice that says keeping the conversation going right now is way more important than making sure every single tiny piece of data gets there perfectly.
See, here's the thing. When you send anything across the internet, whether it's an email, a picture, your voice, it gets shattered into these tiny little things called packets. And the internet has to make a huge decision about how it's going to deliver all those little packets. And believe me, that decision changes everything.
So how does the internet handle this? Well, engineers basically came up with two different kinds of delivery services. You've probably heard of the first one, TCP. But the real star of our show today, the one we're going to focus on, is its faster, kind of wilder cousin, the User Datagram Protocol, or UDP. Okay, the best way to think about this is with a little analogy. Let's say TCP is like certified mail. It is super meticulous, it needs a signature, it tracks the package, it confirms delivery, and it absolutely makes sure every single piece of your mail arrives in the exact right order. UDP? UDP is a postcard. You just scribble a message on it, slap a stamp on, and drop it in the mailbox. It's ridiculously fast, it's super efficient, but, there's no guarantee it'll get there. And no one's promising it won't get a little beat up along the way.
So how does TCP pull off that certified mail level of service? It all starts with this very polite three-step process called a handshake. Before a single bit of data is sent, Computer A basically calls up Computer B and says, "Hey, can we connect?" Computer B answers, "Yep, I'm here and ready." And then Computer A confirms, "Awesome, the line is open." Only then, after everyone agrees, does the real data start to flow.
And UDP? Yeah, it just skips that entire conversation. It doesn't ask for permission, it doesn't set up a formal connection, it just starts blasting data packets, or datagrams as they're called in the UDP world, at the target. And that right there, that's the secret to its incredible speed. No waiting, no handshakes, just pure sending.
And when you put them side by side like this, the difference is just, wow, it's so clear. TCP is all about process, guarantees, you got the handshake, the confirmations, the packet ordering. It's that careful postal worker making sure everything's perfect. UDP just throws all of that right out the window for one thing, and one thing only, raw speed. It really comes down to that one question. Do you want it perfect, or do you want it now? So you have to wonder, right? Why on earth would anyone choose the postcard method? Why would you ever risk losing your data? Well, it turns out that for a huge, huge chunk of what we do online now, speed isn't just a nice little feature, it is literally everything. The answer is all about that trade-off. For a lot of these real-time things we do, waiting for a lost packet to get sent again would create this huge, awkward delay that would ruin the whole experience. It's so much better to just miss a tiny milliseconds of audio or one frame of video and just keep the whole stream moving. And this is where UDP becomes the secret hero of your online life. That split-second reaction in a game that gets you the win, that's UDP. The reason your video call feels like a real, fluid conversation, that's UDP again. Even something as simple as typing a web address into your browser relies on these lightning-fast lookups that UDP makes possible. This quote from our source material just nails it. It says it all, really. A little bit of static, a slightly blurry frame, that's a small price to pay for a conversation that feels immediate, that feels real. A long, painful delay that makes you talk over each other? No way, that's just not acceptable. And that is the whole philosophy behind UDP. But of course, there's a flip side. There's always a flip side, right? The very thing that makes UDP so amazing and so fast, that no questions asked policy, where it doesn't need a formal handshake, is also what makes it a huge target for bad actors. And this weakness leads to a nasty little thing called a UDP flood attack. See, because an attacker doesn't need to get the server's permission to send its stuff, they can just absolutely bombard it with a tidal wave of UDP packets. It completely overwhelms the server's ability to do its job, and it can knock it offline for legit users, like you. So, how does this actually work? Well, it's deviously simple. First, the attacker just floods the server with UDP packets aimed at random places. The server, it's just trying to be helpful.
So it checks every single one, finds nothing there, and then politely sends back an error message for each packet saying, sorry, can't find anything here. The real attack isn't the flood itself. It's weaponizing the server's own helpfulness. You're forcing it to work so hard sending all those error messages that it just runs out of energy and crashes.
Thankfully, this isn't a totally hopeless situation. It's a big problem, but system administrators have gotten pretty clever and come up with some solid strategies to defend against these kinds of attacks.
So how do you stop it? Well, there are two main ways. The first is basically to tell the server, hey, just slow down. You don't have to reply to every single one of these bogus requests. The second, and much more powerful approach, is to build a giant shield. This massive, spread-out network that sits in front of the server, soaking up and filtering out all the malicious junk before it can even touch the real target.
So let's just boil this all down. The most crucial thing to remember is this. UDP is a cornerstone of the internet we use every single day because of its core compromise. It knowingly gives up the guarantee of perfect delivery for the one thing that real-time applications absolutely cannot survive without: speed.
And that leaves us with a really big question for the future. As our world demands more instant gaming, more seamless video, more real-time everything, how are we going to manage this fundamental trade-off? The very thing that makes our internet feel so alive and so instant is also one of its biggest vulnerabilities. Figuring out how to get that speed without giving up on security, well, that's the next great challenge for the internet. Thanks for joining me,